Hi everyone, welcome back to our channel. Today we are going to solve problem number 37 is finding the voltage gain V2 of S divided by V1 of S for the network shown below. So here already this resistor is already in ohms and these are already in ohms, already transformed in S domain. Now what we are going to do is we'll try to find out the equivalent for this one. Okay, so I can see here current enters, current is going to divide. These two branches are connected in parallel, so therefore I am going to get only a single branch, and this is the another branch to what I am going to get. The voltage at this point is V2 of S. Automatically the same voltage is also maintained here, which is V2 of S, and this value is only R2. Now the resultant, these two are in parallel, two resistors connected in parallel. The formula is product of resistance R1 multiplied divided into 1 by SC divided by R1 plus 1 by SC. So when you do it, take the LCM in the denominator as SC. So when you take the LCM as SC, this you can write down as R1 SC plus 1. SC will get cancelled, and you are going to get R1 divided by 1 plus R1 SC is the term we are going to get here. So now this is the resultant term we are going to get here. So this is R1 divided by 1 plus R1 SC with an input voltage of V1 of S, which carries a current of I1 of S. Okay, so now we need to find the voltage gain. So now I'm going to find out I1 of S by using nodal analysis. Current I equal to, we can write it as V by R. Okay, so I am finding the V1 of S with respect to this node. This node voltage is V1 of S minus 0 divided by R. So the current which flows in these two branches is same, this series current. This resistor value is R1 divided by 1 plus R1 SC plus R2. Okay, so this is the value we had got from first equation. Okay, and second one is the same current I1 of S also will flow in this branch. Now I am writing same I1 of S, also I can write down by writing it as V2 of S divided by R2. Okay, so you can see here, consider this an equation 2, consider this an equation 1. You can see here the current is same. I can say that if current is same, the resistance remains same. I can approximate first equation is equal to second equation. Then I am going to get V1 of S divided by R1 divided by 1 plus R1 SC plus R2, that is equal to V2 of S divided by R2. We require the voltage gain, bring this term to the denominator. Okay, so this is V2 of S divided by V1 of S, that is equal to R2 divided by, so if you take the LCM as 1 by R1 SC, then you are going to get R1 plus R2 into, you are going to get 1 plus R1 SC. Okay, so now we can approximate as, so this term will go to the numerator, which is R2 into 1 plus R1 SC divided by R1 plus R2 plus R1 R2 SC. This we are going to get the voltage gain as V2 of S divided by V1 of S. Okay, so this is the formula for voltage gain of the given network. Okay, so this is how to find the voltage gain V2 of S divided by V1 of S for the given network. Okay, just I am finding the common current and I'm approximating it by using nodal analysis. Hope if you are able to understand. If you feel my explanation is good, please like a video, please share with your friends, and if you have any doubts in how I had solved this problem, let me know in the comment section. You are happy to ask your doubts in the comment section. And if you're watching the channel for the first time, subscribe to my channel with the name KV Tulsiram. Kindly support this kind of free channels for the development of students as well for the faculty and the society. So thank you for listening patiently. You were strong. We'll meet in the another video. Okay. So just by watching this video, you'll get some knowledge, and you should write down the given question as it is, and you should solve it again and again. If you get the same answer, so your confidence will develop that no one can give for you. Okay. Thank you for watching. We'll meet in the another video.